Hey everyone, welcome to the channel. My name's Nader. In this video, we're going to go over a bunch of exercises for the ternary operator in JavaScript together. This was an alternative to the if-else conditional statements that we saw in JavaScript previously. This just makes the syntax a little bit shorter, more concise, and in some cases a little bit easier to read. So if you want more practice with the ternary expressions, definitely check out the exercises in this video. Let's get right into them. All right, so as with the previous exercise videos, I have a bunch of comments at the top of each of these files. I'm just going to read through them and then give you a chance to try it out yourself after my commentary, and then we'll go through kind of an example or a possible potential solution together in code. So for this first warm-up exercise, just to get our fingers warmed up, what we want to do is we want to create a variable called hungry that starts as true. Want to create a regular if-else conditional statement, and this is going to be pretty much for all these examples just so that we can really compare if and else together side by side, so it's super clear how to transition from one to the other. Use a regular if-else statement that does this. If hungry is true, I want to print out have a cookie. Otherwise, I want to print out no cookies for you. Right? Super sad. And then we want to kind of make sure this code actually works correctly. So run the code, make sure it works. And you want to repeat these steps 2 and 3 and change the if-else statement into a ternary expression and make sure the code kind of works as expected without any changes. All right, so give that a shot and we'll go through a solution together. Okay, so we're going to say const hungry is equal to true to start. And we want to do an if-else statement to start, right? So we want to say if hungry is exactly equal to true. We can shorten this to just say if hungry, but we'll explicitly check for true in this case. We want to console.log out have a cookie, making me hungry. And if it's not true, we want to print out no cookies for you. So we want to say console.log, and I'll just copy this so I don't have to type it out. All right. So let's see if this works, right? Pretty simple. We saw this in conditionals. It should kind of work as intended. In this case, we expect to see have a cookie. Just make sure I'm in the correct folder. I'll run node and then the warm-up exercise, and we see have a cookie. Fantastic, right? So if I change this to false, we should see that I don't get any cookies and I'm very sad, right? So what I'll do is I'll just kind of comment this code out here, and I want to refactor this code into a ternary expression. Right? So how do we do that? So what we want to ask is hungry exactly equal to true? Right? And I'll do this all in one line. Just so, actually I'll do this over separate lines and then it'll turn it into one line for me probably with my prettier. I want to console.log out have a cookie. Let me just copy that right there. And in the case where we don't, are not hungry actually, where hungry is false, we're going to run into the colon operator, right? Which is the kind of equivalent of the else or the false case, right? So the question mark for the true case, colon for the false case. We want to log out a different statement here. This is going to be kind of no cookies for you. Always mix up what I'm copying. There we go. So in this case, actually it does keep it on separate lines for me, which is nice because it would be too long for one line. But we're asking the question, is hungry true? If it is true, run this code. If it's not true, run this code, right? So same set of code as this if-else statement. You can see technically this could be done on one line, but it's a bit more clear if you split it up like this, just because of the amount of kind of text we have split up over the line. So we kind of shorten it by quite a bit and get rid of all this curly bracket stuff, right? So let's make sure, in this case, no cookies for you, in the case of hungry being false. And if I do true, we end up getting have a cookie. So it works the exact same way. We're good to go. That's pretty awesome. Let's take a look at exercise number 1. All right, so we want to create a function for this one called over 9,000 that has a single parameter, which is going to be a number. So we expect to be passing a number to this over 9,000 function. And the function kind of is going to do the following. It's going to return this string. It's over 9,000 yelling at us, exclamations, if the argument passed in is greater than 9,000. Okay. Otherwise, it's going to say taking a Napa. Okay, in all other cases. Now, I'm not sure if you would get that joke. It's from Dragon Ball Z. But if not, as long as your function works, that's all that really matters. Then what we want to do is we want to kind of do this, run this function, but with a if-else clause, right? So inside of this function, we want to make sure the body of the function uses an if-else clause to actually do these returns. Okay. And we saw in the previous video kind of how we can use if-else and ternaries inside of functions. And then once we're done that and making sure the code works, we want to see if we can redo this with a ternary expression, just similar to the refactor that we did in the warm-up exercise. Okay, and if you want a little bonus for yourself, see if you can actually shorten this even further with the ternary expression by actually using the kind of shortened arrow function expression syntax, which is the one where we kind of remove the curly brackets and the implicit return is there, so we can remove the return statement as well as potentially brackets around the initial parameter. Okay, don't worry about that. That's just a bonus. I'll just show you kind of what that looks like. The main thing is you kind of create this function, try it out with a regular if-else clause first with the returns, and then refactor it to have a ternary expression instead and see the difference. So I'll give that a shot, give you a chance to give it a shot, and then we'll go through it together. All right, so we want to create a function called over 9,000. So we're going to say const over 9,000, and this is going to be a function. So I'll do arrow function there. And it's going to take a single number. Okay, so I'll just say that this is going to be the, let's just say power. Okay, and this function is going to return the string over 9,000 if the argument, which in this case I've named as a parameter of power, is going to be greater than 1,000. So I'm going to say if greater than 9,000. Sorry, if power is greater than 9,000, then I want to return this string. Right, it's over 9,000. Otherwise, I want to return this string, taking a nappa, right? So we're going to say return, taking a nappa. Technically, since this is the only code in the function, we can actually remove the else and just have the return by itself, but we'll leave it at this just so that we can kind of see how the corollary compares to a ternary expression. All right, so let's call this function. Let's do something like 1,000. And if I run this code in a second, I realize that we're doing a return, so I'm actually going to have to say const result and print out the result. Yes, technically this was not in the instructions, so if you didn't do that, that's okay. But hopefully you actually got a chance to test out your function. I want to run node, and this is going to be exercise-1. Okay, so we're going to be taking a nappa if we're at 1,000, and let's add a 0 here. So now we're at 10,000 power. Hopefully it's over 9,000, and it totally is. Look at that. Okay, so let's refactor this, right? So step 3, let's do this, but with a ternary expression instead. So if I just kind of comment this out for now, I'll just say const over 9,000, and this is going to take a power and same kind of thing. So in here is where the difference is. We want to return the result of asking the question, is power greater than 9,000? And if it is, we want to return the string simply it's over 9,000, which is this one right here. And if it's not, then we want to return the string taking a nappa, just like that, right? So my editor is going to actually shorten this again, just onto one line, since it likes the fact that it fits kind of nicely. I think if it was slightly longer, it would leave it as 3 lines. So hopefully you can see what's happening right there. So if I run this again, we're going to get it's over 9,000 using our new function right here. And if I change this to be 1,000 again, we'll see that it is indeed not over 9,000, and we're going to be taking a nappa. Okay. Now, the bonus here was to actually see if we can shorten this with the arrow function expression syntax. And that effectively gets rid of these curly brackets. It actually gets rid of this return. And in theory, if we really wanted to, we could get rid of the brackets around power. So this gets automatically evaluated and returned for this function. So if I save this, you'll see that that's basically the same function, just the curly brackets are gone and the return is gone. And now if I run this with 1,000, I get taking a nappa. If I run this with 10,000, I get it's over 9,000 still. Okay, now be careful with the syntax. Definitely, if it's very, very simple statement like this, sure, I think that's great. Is especially useful in things like maps, which we'll see shortly. However, be careful, because if you want to add more kind of code to this function, then you have to always remember to come in here and add these curly brackets. Okay, let's check out exercise 2 now. So for this exercise, it's another fun one. I want to have a variable that is called wizards that points at this array right here. So an array of powerful wizards from different books and TV shows and movies. Gandalf, Voldemort, Harry, Jafar, Saruman, and Merlin. I should probably say that he who should not be named for Voldemort. Sorry about that. Then we want to map over wizards to create a new array that does this, right? So map is a method on arrays that allows us to kind of loop over the array and return a new array that has all the elements kind of modified in some way according to our function. So if that's confusing to you, definitely check out the video I have about maps with arrays. But we want to map over the wizards array. And if the name of the wizard that we're currently looking at contains the letter N, then we want to return the name, but with all the N's replaced with a star character. Okay, so this is new. We're going to probably have to look up on MDN or something how to do this. Otherwise, we want to return the name, but uppercase. Okay, so let's think about this. So Gandalf has an N, so we want to replace the N with a star, so it'll be a G-A star and then Dolph. Voldemort doesn't have an N, so it's going to be uppercase. Harry doesn't have an N, uppercase. Jafar doesn't have an N, uppercase. Saruman is going to have an N in it, so we're going to do Saruma and then a star. And then Merlin, same thing. The N is going to be replaced with a star at the end. So I'd like you to do this with a if-else statement to start, right? And then I want you to refactor the if-else statement inside of that map to actually use a ternary expression just so you can confirm that it does the same thing with potentially shorter form syntax, and then maybe even the bonus, which is to actually shorten it even further with the nice arrow function expression syntax where we kind of get rid of the curly brackets and the implicit return is there for us. Okay, it's definitely quite challenging. You're probably gonna have to look up on MDN. I didn't put any hints as to what to look up because I want you to get more practice with actually how to Google things, but we'll do it together after I give you a chance to try it yourself. All right, so to start, let's go ahead and create a const. We'll say wizards, and this is gonna equal to this array right here. Perfect. And then I want to map over wizards. So I'm going to say wizards.map, and we're going to get each wizard one at a time, and we're going to do something with that wizard. So the first thing we want to do is check to see if the name contains the letter N. Okay, so let's do this. So I'm going to pull up Google here as the Halloween theme because it's that time of year. But I want to say JavaScript string, I guess, contains a letter. All right. So there's a whole bunch of different things here. It looks like there's an includes. How do you check if something includes? Is there an MDN article here? Maybe not. Maybe if I scroll further, you know, let's just go Stack Overflow. Maybe you did a different resource. That's totally fine. I'll just go Stack Overflow because that's one thing that a lot of programmers like to use. Let me zoom in a little bit here. How to tell if a string contains a certain character in JavaScript. Let's see some answers here. You can use index of greater than -1. That seems kind of ugly. That probably does work. It looks like there's some new syntax here. Does this string include that thing? Include that thing? Maybe some fancier string syntax over there. So okay, so I kind of like that. Let's try this one here, right? They even included the documentation for includes here, which is very helpful of them. So we can say sentence word that we're searching for. Does it include that in the sentence? They're doing a very complicated thing here. And then it's saying that the word fox is in the sentence using a ternary expression, funnily enough, right in there. Okay, perfect. So let's try that out. Let's see how that works. So we're gonna say if the wizard dot includes, then we want to search for the letter N. Right? So if it has an N in it anywhere, then we want to do something. What do we want to do? Well, we want to replace all the N's with a star. Okay, so now we got to go back to Google and figure out how to do this. So I'm just going to go back to kind of Google over here. I'm going to say JavaScript replace all letters in a string. Okay, answer use the replace method. Okay, this is from like a tutorial somewhere. There's like a Stack Overflow, fastest method to replace all characters in a string. Maybe I'll take a look at that real quick, open it in a new tab, and then I'll look at this Mozilla. Oh, look at that, replace all, MDN, my favorite resource. Replace all, a pattern, it can be a string or regex. We haven't looked at regex yet, regular expressions. We'll look at that in our future videos. Looks like we can replace all on this string, dog with monkey. I love monkeys, I love that idea. Sorry to those of you that like dogs more. The lazy monkey. Okay, great, that's cool. This is exactly what we want, right? We want a lazy dog, lazy monkey, if the dog, if the monkey. Perfect. So we can just do kind of the string and then dot and then replace all. Now I'm going to bother checking the Stack Overflow because it looks like this kind of has everything that we need, right? Googling is always going to be different. The results for you might be different than me. You just want to get in the hang of kind of searching and opening up different tabs and looking for potential answers as you're doing that. So I want to say return wizard dot replace all. and I want to replace all the things that I want to replace it with, and then the thing I'm replacing with the thing that I want to replace it with. So what do I want to replace? I want to replace all the ends with stars, right? Just like that. Okay, so I'm going to take the actual wizard itself, replace all the ends with the stars. And otherwise, we want to return the uppercase version of the name, right? So if it doesn't include n, we want to return the wizard dot to uppercase. There we go. All right, and we've seen that function before. So quite a lot going on here. I'm going to actually assign this to a variable. I'll say updated wizards, and I'll console.log out our updated wizards. Okay, I'll just pull up our sidebar here and clear that out for us. I'm going to run node exercise 2, and fingers crossed. Okay, check that out. That's pretty cool, right? That works pretty well. So Gandalf has a star replaced there. Voldemort, Harry, Jafar don't have an N in them, so they are left alone. And then Saruman and Merlin, since they end with the letter N, they got theirs replaced as well. Okay, so just to kind of check this out to see if this really works, maybe I'll add a couple more N's here to Gandalf, right? Make it super long and rerun this code. And there we go. We get it censored out, right? That's pretty awesome. Pretty cool. Okay. Definitely play around with it. A lot of fun once you get used to kind of this stuff. There's a lot of power to kind of how you can make this work. So let me undo that and undo that one more time. And now I want to just replace this with a ternary expression. So how do we do that? So I'm actually just going to comment or copy this and comment it out. And I'm going to kind of paste it down here just so we can have some reference point. So the if statement, right? We can actually replace this entire thing with a return directly in here. So I'm going to return the result of does this thing include that thing? And the curly brackets can go away. So can this else clause, and so can these returns. Okay. And the only thing I need now is to put a question mark here and then get rid of this semicolon because now this is an entire single expression, and then put a colon here. Okay, so hopefully you can see how that refactor works. I did it pretty quick, but I'm now asking if I ask this question, does wizard include n? Yes, well then do this, return this thing, right? Because we have a return. No, then return this thing instead. Okay, and if I save this, let's see what we get. If I run that, look at that, right? Pretty awesome. It actually works the exact same way, which is pretty wonderful. Now we can shorten this even further, right? Our last bonus was how do we do this with the arrow expression syntax. So we can actually get rid of these curly brackets here. We can get rid of the return, and then we can get rid of the semicolon here, right? And if I kind of shorten this that way, you can see that technically this can fit on like 1 or 2 lines. I'd prefer this to go onto multiple lines, but now we are returning this expression directly, and we got rid of those curly brackets. So it's even shorter syntax. This is what you'll actually see happen most of the time with things like map filter, for example. So if I run this code, what we'll see is I actually get the exact same result as I did before, which is pretty awesome. Okay, let's take a look at exercise 3. So for this exercise, we want to create a variable called characters that points at this array right here. Okay, so a bunch of characters: Han Solo, Spock, Darth Vader, Yoda, Neo, and Sarah Connor. So what we want to do is we want to filter over the characters and create a new array that does the following. So we want to use filter over this array, just like we use map over the array in exercise 2. So if you're not familiar with filter, I have a video on that as well on the channel, so you can check it out. But effectively, we're going to kind of filter out things that are either true or false within this array. So we want to start this off with a regular if-else statement inside of this filter function. So if the name has a space in it, okay, so like Han Solo has a space, Darth Vader has a space, and Sarah Connor has a space in between their names, right? So Han space Solo, right? So if it has a space in it, we want to keep it in the result. So we want to return true. Otherwise, we want to filter it out. So we want basically an array with Han Solo, Darth Vader, and Sarah Connor. We want to filter out Spock, Yoda, and Neo. Okay, and use a regular if-else statement for this. And then same thing as before, refactor it with a ternary expression, and then even refactor it further with an arrow function expression syntax. So give that a shot, and then we'll go through it together. All right, so I'm going to create const characters, and this is going to equal to this array right here. Perfect. Then I want to say characters.filter. and we're going to get each character here. And for every single character in our array, we want to return true if we want to keep it, and false if we want to get rid of it. Okay, so we saw that in our exercise 2, we can ask if something includes something using the include. Okay, so we want to include instead of the letter N, does it include a space? So if character dot includes and then a space, right? Then what do we want to do? We want to return true, right? Because we want that character to be kept in the result. Otherwise, we want to return false. And we want to filter out that character. Sorry, that got reformatted there by my VS Code. We want to filter out that character and not keep it inside of our resulting array. So I'm just going to say const filtered characters, which is going to be my result. And I'm going to log out that new array of filtered characters. So I'll just say console.log filtered characters. And let's hopefully see Han Solo's in there, Darth Vader's in there, Sarah Connor's in there, but we don't have Spock, Yoda, or Neo, right? Missing our friends. So I'm going to run a node, exercise 3 in this case, and look at that, right? We have our 3 characters that have a space in there. Perfect. So now to turn this into a ternary expression. So the same thing as before, since this is inside a filter, what we can do is we can kind of replace the if with a pretty much nothing. In this case, we want to return something, so technically we have to replace it with a return. That'll allow us to get rid of these 2 return keywords. We can get rid of the curly brackets, the else, and now we can also get rid of the intermediate semicolon because that'll end the statement. For the true case, we put a question mark. For the false case, we put a colon. Okay, so we're saying, is this true? Then return true. Is it false? Then return false. Okay, so if I save this, it'll reformat it for me because it nicely fits on one line. And I rerun this, you'll see we get the same result, which is pretty awesome, right? But check this out. If you went as far as actually returning the shorter syntax, let's see what we get. So we can return get rid of the return, get rid of the curly brackets and the semicolon, right? And now we have an even shorter syntax. And if I run this, we'll see that we still get the same result. And I didn't put this in here, but you may have realized that we can actually do something really, really cool, specifically in the case of filter. Okay, so what is that? Well, includes actually returns to us a Boolean. Okay, so includes is going to actually evaluate to true or false already itself. It's going to return true or return false. That's the entire purpose of the includes function. Okay, so what we can do is we can actually get rid of this ternary entirely and just return the result of character.includes. Now I know this is a video about ternaries, but if you do want to go this far, you can definitely even just do this. And if I run it one more time, you'll see that we actually do get the same result, which is pretty awesome. Okay, this is definitely unique to filter and is used all over the place in real code. So just wanted to show that to you as another example. So I hope that was valuable and these exercises provided you enough of a challenge. If you did like the video, I'd love it if you could like the video on the channel, subscribe to the channel as well, and leave any comments that you feel you maybe want more practice with this or more exercises or even harder exercises if you want, and I'll try to think of some. Do you actually end up using these ternary expressions a lot, and what kind of method do you actually use them in? Do you use them mainly with map filter and things like that? Or do you actually use them to return function expressions, for example? I'd love to hear in the comments. What we're going to do in the next video is we're going to go over the switch statement. And that is another bit of syntax in JavaScript that's going to allow us to shorten, to some degree, sometimes lengthen, but most of the time shorten or make some of our code simpler in the context of conditional statements. Now it only works in certain cases, and we're going to kind of go over where it is useful and where it might be less useful in that video. So if that sounds exciting to you, I'll see you in that video. See you later.